This is becoming fun. Practice questions number 6. So here we're given a question: f of x equals the root of x plus 2, and we're given g of x to be equal to 3 all over x. So this is for f of x and this is g of x. Now you're told to find f plus g of x. Now by definition, it's like you're expanding. F plus g of x is simply as if you're expanding f times x, which is f of x, plus g times x, which is g of x. That's a very good way to kind of remember the definition. So if you're given f plus g of x, is the same thing as f of x plus g of x. And then what we have here as our f of x is x plus 2 plus your g of x, which is 3 divided by x. And then that's your answer. That's all. You don't have to do any other thing again. Now the next question says, find the domain of f plus g of x. Now this is like the combination of two different things. You want to find the domain of f in conjunction with the domain of g. Now this is just simply the intersection of the domain of f and the domain of g and the domain of g. So the intersection of the domain of f and the domain of g, that is the domain of f intersect the domain of g. So let's go ahead and find the domain of f and then the domain of g. So the domain of f, so you recall the f we were given up there, our f of x equals the root of x plus 2. So the domain of f, that is the domain of f, is going to be the set of all numbers excluding the numbers that would make what we have in the root sign to be a negative number. So you recall, whenever you have the root of a negative number, say -3, this is going to give you a complex number, which is not what we want. So we have to exclude all numbers that are less than 0. That is, the only valid numbers are only the numbers that are greater than or equal to 0. So the domain of f is going to be the set of all real numbers such that what we have here, that is x plus 2, must be greater than or equal to 0. This is the domain. Any other number sets this whole thing here to be a complex number. So in other words, the domain is just x such that, so when you bring this here, it becomes x greater than or equals to -2. This is the domain of f. And then for the domain of g, so our g of x equals 3 divided by x. So the domain of g is just going to be, now since this is a rational fraction, the domain is just going to be all numbers excluding the numbers that would make the denominator to be 0. So you have to exclude those numbers. So it's going to be the set of all real numbers such that x does not equal to 0. So this is the domain of f, and then this is the domain of g. So we said the domain of f plus g of x is the intersection of the domain of f and the domain of g. Now how do we interpret this? Let's see this on a real number line. So you recall, on your real number line, let's say you have something like this. And now I want to represent this on the real number line. So we have x greater than or equals to -2. So this is, let's say this is -2 here, and let's assume this is 0 here. So greater than, so let me erase this. So this is my so let me use this for my, so it says greater than or equals to -2. So it's greater than -2. So it keeps on going to infinity because it doesn't have any limit. It says just greater than it. So then it says equals to, greater than or equals to, so it simply means including -2. Now the next one here says the domain of g, which is, so that means the domain of f is just going to be everything in this area here, like this, like that. Now the domain of g is all numbers excluding the point 0, excluding the point 0. Now how then do I represent this? So let me erase this. So this is the point 0, So you can see I've excluded the point 0. It says every other thing is in the domain. So that means to the left, to the right are included in the domain of what's the name? The domain of G. Yep. So all numbers. Now you remember we said the domain of f plus g of x is actually the intersection of the domain of f and the domain of g. So anywhere you see the two colors is going to be in the domain. So if you observe here, you can see this part here has been excluded. So let me write the domain now. So the domain of f plus g is going to be, you can see this is where the intersection is, from here to here, and then from here to here. That goes like this. So representing this, so you can see -2 is inclusive, so we say -2 less than or equal to, since -2 is inclusive, x now less than 0. So you recall that 0 has been excluded. You can see here is excluded, so you do not put the equality sign there. And then for the other side, it's going to be x greater than 0. So also you do not include the equality sign here, because you can see that 0 has been included. So therefore the domain of f and g is actually the union of these two sets. Another way of writing this is by saying -2, you put square brackets, and -2 is inclusive, it stops at 0. Now 0 is excluded. Now union, since 0 is excluded, we do not put 0, then it keeps on going to infinity. Now this is your domain. So either this or this is the domain of the function f plus g of x. Now here it says we should find f plus g of 3. Now to find f plus g of 3, you recall that this is f plus g of x, which I'm going to write down here. This is what we call as f plus g of x. So I'm going to write that down. So our f plus g of x, f plus g of x equals the root of x plus 2 plus 3 divided by x. Now this is what we got as f plus g of x. So to find f plus g of 3, that's just going to be the root of, so anywhere we find x, we replace it with 3. So put 3 plus 2, then plus 3 divided by, so we have x here, so we replace it with 3. So and then this gives us the root of 3 plus 2, which is 5, plus 3 divided by 3 is 1. So therefore your f plus g of 3 equals the root of 5 plus 1. So this is the solution of the problem, and then that completes the whole problem. Thank you.